Exceptions are an important feature of many programming languages that allow the program to signal when it can't proceed and get the correct answer. There's something wrong with the data that it's manipulating. It's detected an error condition. In Python, you can not only raise exceptions, but you can handle them. You can wrap a particular piece of code up in such a way that any exceptions that is generated transfer control to special code that you've written to deal with the exception. That's a pretty handy feature, as you'll see. Our Python programs have been dealing with exceptions for a while now. Let's talk in detail about how that works. So the basic question we have is, what should we do when our procedure has to stop execution because there's some sort of error condition? We have sort of three choices available to us. One is we can fail silently. We can substitute in the appropriate default values and continue execution. And the advantage of that is that the program never fails. I always get some answer back. But basically, that's a really bad idea. The user gets an answer, that's okay, but they also get no indication that the result that they got may be suspect because of some error condition and the substitution of default values. So in general, that's not the way we should go. A slightly more tasteful approach is to return a special error value. For example, if I had a procedure that was expecting to produce a number, I could instead produce the Python object none to indicate that no number was available, that some error happened, and here's my indication, a special return value. It can sometimes be a challenge to figure out what special return value is distinguished from all the other possible return values, but assuming you solve that problem, there's sort of a bigger issue. Because if I have a procedure that can return one of these special values, then whenever I call that procedure, I have to include code in my own body which deals with the fact that it has to check for the special value and then deal with whatever the consequences are. And what I have to do is say, well, I don't know what to do with it. It must be an error that I'll give to my caller. So I generate my own special value, whatever that is, and return that to my caller. And so what happens is that all the procedure calls get surrounded by special if tests to check the results and deal with any error conditions reported in this way. So it really complicates the program. Instead of this very simple program of nested procedure calls, I end up with a lot of code that's checking for special case values. So it sort of gets the job done, but it's really a burden on the programmer. Happily, Python provides us a tasteful alternative. We can raise an exception. So this is a condition that will basically propagate up through all the nested procedure calls, and each procedure call will have a chance to deal with the exception. If none of the procedure calls, the nested procedure calls deals with the exception that was created, and in fact the Python interpreter will do the right thing and create this nice little error message to the users, giving a backtrace showing exactly where we were in the execution of the program, and print out this descriptive string. So the way we actually create an exception inside of Python is we use the raise statement, so a raise keyword followed by the creation of whatever type of exception we're trying to raise. In this case, we're just a generic exception, and all the exceptions here take as their argument a descriptive string. If we wish, we can provide handlers for exceptions. So, for example, if I'm going to do an operation which might create an exception and I'm willing to deal with that, what I can do is embed those statements inside of the body of a try statement, followed by some code that will deal with the exception. So the way this works is that as I'm executing statements in the body of the try, if any one of them throws an exception, Python will look in the list of exception handlers to see if one of them will actually deal with it. In this case, I'm willing to deal with any possible exception. And so any exception that happens in the body of this code will result in the execution of this Python statement. So just to summarize, exceptions inside the body of the try will then cause Python to look through the exception handlers listed after the try statement, and whichever one matches first, it will then start executing statements from the body of the exception handler. In this particular case, what can happen is that the open statement can discover the file doesn't exist and create an I/O error exception. What happens is that I want to catch that exception in my code, and instead of getting some sort of obscure I/O error, I turn it into a generic exception with a more sensible error message saying can't open grades file. If you'd like to see more about the whole how try and except works, you can look in section 8 of the Python tutorial. So usually a handler is only meant to deal with a particular type of exception. And sometimes we need to deal with cleanup actions before continuing. So in this case, I've refined my example a little bit further to say, look, I have an I/O error here. I want to deal with the fact that if this open fails, I know the type of error I'm going to get. I'm going to get an I/O error. And in that case, I'm going to print out a very specific error message and cease execution of my program. And what I've done is I say, look, I can't open the grades file. And I've also included, I've captured the actual error object, the exception object that was created by whatever the low-level exception was. And I report that as well as my generic error message. Separately, there may be some arithmetic calculations on the errors later on, and I can catch those and print out another informative error message, in this case saying, oh, there's a bug in the grade calculation. So this differs because it's a much more nuanced handling of errors. I'm distinguishing I/O errors that come from the open statement from arithmetic errors that come from the code that's processing the grades. And I can have as many different statements as I want dealing with the different types of errors that I expect to get. We've seen a lot of the common errors. You get syntax errors, that's when your Python can't parse a program. A name error when local or global name can't be found. An attribute error, which is when we have an attribute reference that fails. We've asked for an attribute of an object that doesn't exist. We get a type error when that's when the operand doesn't have a correct type. So I'm asking to add a string and a number together, and the plus operator doesn't know how to do that. So it's an illegal type of operand. A value error in which the operand types are okay, but the value is illegal. For instance, division by 0. I mean, 0 is a perfectly good number, so it's in general a legal operand to divide. It's just that its particular value of 0 in the denominator causes us to say, aha, we can't do this particular division. And we just talked about I/O error. And if what you want to see a list of all the different kinds of errors and what they mean, you can look in section 6 of the Python standard library. There's a couple other handy extensions to try. We've talked about the except statements that can follow try. We can also have an else clause after a try statement. And this is will be executed when the execution of the associated try body completes with no exceptions. So this is what we would do if the try body completes successfully. And finally, there's the finally clause. And so this is a clause that's always executed after the try statement and all the else statements and except clauses that apply. And even when one of these clauses, either the try or the else clause or the except clause has which might be inside a loop of some sort or inside a procedure call, they may have executed a break or a continue or a return. That's fine, they're allowed to do that, but before we actually finish the execution of this particular try statement and all of its clauses, the body of the finally will be run. So we often put in cleanup code there that should be run, for example, closing any open files that we created, no matter what else happens, errors or not. To see how this works, let's look at a little example. I've created a divide routine, which is going to attempt to divide the two operands and return the result. So because that may fail, particularly if y is 0, what I'm going to do is embed the operation that I know might raise an exception inside a try statement. And then I will, in the case of a division by 0, detected by the low-level Python divide routine, I'm going to print out division by 0 as the message I return. Otherwise, if I successfully complete the divide operation, I'm going to print out what the answer is. And finally, in either case, I'm going to hopefully execute this finally clause. So let's see how this works. So I'm going to go off and say divide of 2 and 1. So in this case, because there were no errors, the body, this thing completed successfully. We actually put a legitimate value into the divide local variable. And then after the completion of the try statement, since there were no exceptions, we executed the else clause, which basically says print out this answer and return. So it result is 2, is what it printed out. And then after I finish the else clause, this will be executed here. And we can see we actually executed the body of the finally clause, which printed out the executing finally clause statement. Now, let's do a divide that will cause an exception. So in this case, execution of the body did not complete successfully. It raised a 0 division error, which I actually have a handler for. So when the body of the try raised an error, Python looked down my clauses following the try and discovered that I had a handler, declared an exception handler for the 0 division error, which prints out division by 0. So it does that. It's now done with the try, and it's going to return. But before doing so, it once again executes the finally statement. So finally gets executed whether or not there was an exception. Now let's try one final experiment. Let's try some operands that we would assume will raise a type error. And in fact, we do get a type error, like so. And since that error is not caught anywhere, it actually will percolate all the way up to the Python interpreter, and we get the standard sort of error result where we get a little traceback of where we were, followed by a description of the little descriptive string that was part of the creation of the type error object that we created, which was a description of what the problem was. But notice before we got the traceback, even though we had no exception handler, so we weren't going to do any except clauses, and since it didn't complete successfully, we weren't going to do the else clause, we still nonetheless executed the finally clause and printed out our message.